By way of introduction, I work at Meta, and I've been working on maps at Meta for the last 6 years. I've worked on OpenStreetMap editor tools, and I've also worked on the Overture Explore site, which I was jazzed to see Chris include in his talk this morning at the plenary. So before we get into the actual use case, though, I need to take you through a little tiny bit of an explainer for Overture Maps data. So it is vector data. I will talk about how I'm actually trying to catalog the vector data. But for starters, we release a lot of data each month. It's kind of a huge blob of data. It's half a terabyte. It's hundreds and hundreds of GeoParquet files. And there's tons of licenses. There's a lot of different types. We've striated the data into several different themes. So these are things like buildings, places, addresses. And each one of those themes can have sort of subsequent types underneath it. So we have a base theme that has like 5 or 6 different types underneath it. And so if you want to know a little bit about Overture data itself, then we do actually have a workshop this afternoon that Jennings will be doing. So I encourage you to go there. Before I go on, though, you see we have this sticker here. And this is kind of illustrative of what I'm trying to do with STAC, is that the important thing for me is to be able to get data into people's hands and let them know where the data is, and also what the shape of the data is. So that is a visualization of all the different bounding boxes that we've sort of spatially indexed all of the GeoParquet into in convenient sticker form. So we'll be handing those out later. So how did I get here talking before you all? Well, as a developer of the Explore site, I had a use case. I needed to be able to power this download button that you see in the upper right here. So we wanted, as part of Overture, to do things in a very cloud-forward way. I didn't want to stand up a download service. I wanted to do everything from blob storage. So all the data you see visualized here is from PM Tiles. Thank you, Brandon, who was in the room, for standing up that pipeline. And all of the data that we download comes from our GeoParquet that's also out on blob storage, just sitting there for anybody to crawl and index. The problem is when people clicked this download button, the site would send out something like 1,200 HTTP requests to object storage, which took a while. It wasn't cacheable. So I looked at this and said, okay, great. What do I do with all of this? How do I solve this problem? One thing I noticed while I was looking at solving this problem is that by shopping my ideas and concerns around with other people in Overture is that me, the software guy, and all of the data folks had very broadly similar questions. And a lot of these questions are answerable by the metadata that you find in STAC. So things like, okay, which files out of this whole mess have the bounding boxes that have the data that I need? What's the schema structure like? So I was very fortunate, actually, to be talking directly with Seth Fitzsimmons in AWS. He was one of the folks that helped stand up the spec. And so he looked at what I did to solve this problem, which is I immediately, like any good software professional, hand-rolled a JSON format that was just of my own devising that solved my immediate use case. And Seth looked at it and he went, "You realize that this is a solved problem. You can just do this in STAC." And I went, "No, I did not. So how do I do that?" So he helped me kind of get started on this journey. So I looked into STAC. I started out by just trying to write a static catalog to describe Overture's data. And then, after joining the CNG meetup, I realized, oh, there's some other formats that I could do to stand this up too. So I'll talk a little bit about the APIs that Matt touched on, and also a little tiny bit about GeoParquet. Okay, so some of this will be review, and that's kind of by design. I specifically looked at all of Matt's slides, which he was very helpful in sharing with me before the conference so that I could figure out what he was going to talk about. So we start at the top with these catalogs. Catalogs can have subcatalogs. Those can have collections, which are backed by items, which are backed by assets. And in this particular case, for Overture, I decided to make the mapping of a single GeoParquet file. So we have hundreds of them. And so there's hundreds of items within this whole catalog. So what does this look like in my implementation? So I'll go back and forth here a couple times so you can see. So again, at the top level, we have catalogs and then subcatalogs, then collections. So going into Overture's format, as I mentioned, we have a bunch of themes. There's places, there's addresses, there's buildings, there's transportation. Each one of those formats has a subordinate bunch of types. And as Matt touched on earlier, all of those types are pretty similar in their schemas. They all have sort of the same properties. So it made sense to me to put each one of those types into a collection because they all, broadly speaking, share a similar data schema. It did not make sense to me to put, say, places and buildings in the same collection because, as Matt just talked about, if you're only interested in places, you don't want to have to do all of that filtering every time you want to query the stack index. So that's one of the reasons I did that. So there were questions about extensions, and I did actually look at all of the extensions. There's a lot of them. But I did find this one, and this is perfect for Overture's use case. We release a lot of data every month, and this extension lets me define and say, hey, not only do we publish this data on both on both AWS and Azure, but it's also not request or pays. It's free to download, and to give you an idea of like the URL schema that we use to build these file paths. And under the subcatalogs, I mention this because there's really not a whole lot interesting here. The subcatalog is pretty much just a collection of links that point to the collections underneath it. And so Matt had talked earlier about how when you go to like an API or STAC GeoParquet, all the catalogs are kind of done away with. And I think that's kind of why, is that there's really not a whole ton of metadata that I want to impart at the subcatalog level. Really the important bit is once you get down to the collection level. So again, as I mentioned, what I'm trying to do with these collections is just give you the very basic data. The entire collection all shares the same column names, basically, the same data schema. But what's interesting is once you actually move into the item level, all of the items in that collection have different bounding boxes. So each one of those partial GeoParquet files that we ship has its own bbox. So that is defined at the per item level. So you get a static reference to exactly where you need to go on AWS to find this GeoParquet. And you also get an idea, okay, here's the actual bounding box that is associated here. So that's the information that lets me solve my use case. I just want to know, where do I need to go to download this data? I can immediately discard something like 95% of all of the files that we ship monthly by just knowing which bounding box to look at. So, some other formats that you can do to both consume or produce STAC, and Matt has already talked about these a little bit. I won't go into insane levels of detail here, but here is an actual visual map of the real segments catalog. So this is one of 14 catalogs that I'm creating as part of my STAC creation, and it's kind of a lot. There's a lot of JSON here, and frankly, Overture's STAC catalog is not that complex. There's not a ton of files. Some STAC catalogs have millions and millions of files. So you're talking about like gigabytes of JSON, especially if the JSON is well formatted and there's a lot of empty space in it. This can be a lot to sort of process. In addition, if you want to do any sort of like filtering or querying on this, you have to load everything into memory before you can actually do any useful work. So that's where the APIs and STAC GeoParquet come in. So when I was first looking at APIs, I was a little surprised because over here on the right is just a screenshot of the planetary computer stack. And I immediately noticed what Matt mentioned, that there's a single root level catalog, and then everything else underneath that is just a collection. So I did a Control F on collection, and you see it's just repeated like hundreds and hundreds of times. So that gave me a good intuition that the way I had structured Overture's data was pretty good, in that this is actually sort of a validation that at the collection level, we want to keep things kind of broadly similar from a database perspective. So this API is queryable. We were going to have a third talk about that, but it sounds like there will be some others throughout the week. And this is definitely better than having to parse and read your own static JSON catalog. So if you want, you can spin up a client and then ask for all of the catalog data that conforms to a particular like time or for a particular bounding box. The cons here are really on the publisher side in that you have to actually maintain the database and make sure it's up to date. And if you're releasing monthly data like us, you have to do some work every month to keep that up to date. And of course, there's the actual operating expenditure of maintaining the API and maybe having like a staging environment and a prod environment. And then I have the same exact link to the one that to the article that Matt did. Is that there's a proposal for STAC GeoParquet, and so in this particular case, Overture is shipping GeoParquet files, but we're also looking at standing up an index on a per type basis that also uses GeoParquet to describe the GeoParquet files. So Parquet is self-describing. You can go into a GeoParquet file and get all of the metadata out of it. And it also supports compression, which means that it's much easier on your disk usage than gigabytes of JSON. And again, just like the APIs, STAC GeoParquet pretty much applies to collections. So if I wanted to stand up an equivalent STAC catalog using STAC GeoParquet, then I would have 14 of these GeoParquet files to describe each one of our types. Cool, that's it. So questions for me or for Matt with the time that we have remaining? Go for it.
We still have time for 3 or 4 questions. Okay.
Hey, thanks so much for the talk. So a bit of a newbie question. I thought I was with you guys in the sort of structure of STAC, and I understood down to the buildings collection. Then when you started talking about the items, I was expecting items to map to like features, like a specific building. But am I thinking about that too granularly? An item is because I think you said it mapped to the GeoParquet file.
Yeah, so you can think about it as either like imagery is sort of STAC's killer app use case. That's what it was originally designed for. And so you can have an item that points to a particular like GeoTIFF file. And in my case, I decided to striate it to a single GeoParquet file. I'm not sure if there are other ways to aggregate things, but yeah, if I were to try and describe every single feature in Overture in an item, I would basically be creating a one-to-one like scaled map. It would be a catalog literally larger than the original data set itself. So there is going to be some level of indirection and sort of like grouping inherent to creating metadata like this.
Got it. Okay, thank you.
One comment. The more
No, Chris, one moment.
The more common case, if you have vector data like a GeoParquet file, would be you just have a collection asset that says this collection is the metadata for the entire thing. GeoParquet is special because it can be partitioned and with massive amounts of data, so that's really what those bounding blocks are partitions of an overall collection. But your kind of common case, if you don't have this mass amounts of data, would be you just describe the collection level metadata and point at a single GeoParquet file or at a features API if you wanted to be more dynamic.
I'll also add to it just a mile. Yeah, I think one thing that really helps to understand this is like imagine you had building footprints, right? There's way too many for the whole world, but like you divide it up and partition it by counties or by state in an area. And now each one of those is a STAC item because you might have a user that's like searching for a geographic area and they're like, I want these states or these counties, and then each one of those. So this is like the partitioning idea, like each building has a STAC, GeoParquet file for that geographical region. So your STAC is really just a discovery to get to that data underneath.
Okay, we have 2 more questions.
Thank you. So coming from a computer science background, I have a question about where is this actually hosted? The catalog itself. Is it local or do you deploy it on a server? Where is it located?
So if you're coming from a data provider perspective, you do have those sort of 3 options. You can make a static catalog and publish it somewhere in blob storage. You can make a static catalog with STAC GeoParquet, in which case you're just writing Parquet files as opposed to JSON files. And then there is the taking on the actual like work of standing up one of those APIs yourself. So I have only used the I haven't used the fast API, but I have used STAC Server. And Stack Server isn't just like the core software to serve, it's also all of the CDK and like automation you need to deploy into an AWS environment. I'm pretty proficient at AWS, but I would say that the documentation for Stack Server is excellent. I got a server stood up in like a couple hours, having never touched it before. But again, the problem there is not just the initial stand-up, it's the carrying and feeding of maintaining all of that data and making sure that you keep it up to date.
Thank you for the talk, first of all. I think this kind of ties into what you already just spoke about, but you were sort of mentioning the trade-offs of standing up an API versus static catalog, and it sounds like you went the route of using the API. But then I was also going to ask for the STAC GeoParquet, is that something you're using today, or is that still sort of immature and that's something you want to use in the future?
That's something, so we're considering everything. This is kind of all a late breaking journey for me. Like I started off with just the static catalogs. I didn't really understand that the APIs existed when I first started out. I think the GeoParquet is probably the way I would go. That's only because of Overture's overall approach to building software and services is like we try to do everything cloud native, really harkening back to Chris's talk this morning of like, if you can build something in a cloud native format and put it up on blob storage and then back away slowly and allow other stuff to happen, I think that's probably the way we'll do it. It's a lot easier for us than standing up a server, although we are kicking around the idea of standing up a server. Overture to this point has been a little allergic to standing up services precisely because of all of the issues I mentioned. We really want to prefer to be like a data delivery mechanism. So I think STAC GeoParquet is kind of our sweet spot. We're big fans of GeoParquet in general, but I don't want to rule anything out. I think there's plenty of addressable audience to just doing a regular JSON catalog and releasing them both every month and publishing them.
Great, thank you.
Sure.
I would say if you're a provider of data, like a lot of the idea for Stack is to make it as easy as possible for providers. And the API is easy for a provider like Planet, where we already have a huge data API and you just kind of put this other facade on it. If you haven't done Stack, like GeoParquet is, I wouldn't say 100% there, but it's pretty mature. But like that to me is the answer going forward. And then you can, if you have that, then somebody else's API, like EarthSearch, could use that same GeoParquet. So like as a publisher, if you're looking to do the simpler thing, I would lean towards, as it matures, just STAC GeoParquet. And then the cool thing you left off on yours is that like JSON also doesn't have an index. Like you can't do an indexed read, whereas GeoParquet does. So you essentially get most of what you get from a server API if you use a client like DuckDB that does like remote reads. So it kind of gives you the best of both worlds. The only problem is it's not quite as mature. We haven't written it up and talked about it enough. You can't access a ton of Sentinel-2 and Landsat data in it yet, but there's like one final push to make, but it should be an answer. There's always going to be a place for the APIs, but I think that should be more a small number of people who stand up those APIs, crawl everybody else's STAC GeoParquet, and serve it up.
And as a shameless plug, if you want to learn more about GeoParquet, come by to the workshop at 1:15. We'll be talking more about that.
Okay, great. Now it's lunchtime. Thanks again, Matt and Ben.